Hello everyone. In today's video, I am going to explain assembly language program to convert hexadecimal number into decimal equivalent. In this video, I am going to explain this program in detail in stepwise. At the end of this video, I am going to show you output of this program using Kill Microvision. So let's start with the video. Now, before going to program directly, I will show you how to convert hexadecimal number into decimal number. So the conversion method I am going to explain here, and after that we will go for writing of a program. Now, for example, let's take the hexadecimal number as F9H. You know that hexadecimal number is a combination of digits from 0 to 9 and alphabets from A to F. So here in this example, we have taken the hexadecimal number as F9, and this number we are going to convert into decimal equivalent. So the method to convert hexadecimal number into decimal is to multiply the digits of hexadecimal number by the weights of 16. Now let's start with the conversion. Now step number 1 is you need to multiply each digit of hexadecimal number by weights of 16. So we have to start with LSB. Now here in this case we have multiplied number 9 by weight of 16, that is 16 raised to 0, plus F into 16 raised to 1. Now after that you need to make the calculation. So F stands for 15 in decimal, so I have replaced F with 15 and I have calculated the weights of 16. So my answer is now 16 into 15 plus 1 into 9. So if I calculate this, I will get the answer as 249. Now this is the manual method to convert hexadecimal number into decimal equivalent. That is, for hexadecimal number F9, I am getting answer as a decimal equivalent 249. Now for this we are going to write the assembly language program. So let's start with the program, and for this we will be getting the answer as 249. So let's start with the program. This is the program to convert hexadecimal number into decimal number. In order to understand this program, I have made 3 parts. In one part, program is written. After that, I have written the meaning of each line of the code. And the third part is output that we will get after execution of each instruction. Now let's start with the program. The first line of the program is org00h, which indicates starting of the program. Org is nothing but origin directive, which is used to indicate start of the program. At the starting of every assembly language program, we need to write this org directive. Now the next is move a comma hash F9H. The meaning of this line is we are moving the hexadecimal number that we want to convert into decimal equivalent into register A. And as an output, I have taken A is equal to 249 because when we do the calculations, we need its decimal equivalent for calculation, and therefore I have mentioned A is equal to 249 as an output. Now let's go for next line. that is move B, comma, hash 0AH. We are moving the number 0AH, that is nothing but 10 in decimal, into register B. Why we have taken A or 10? Because we want to convert hexa number into decimal equivalent. The base of decimal number is 10 and therefore we have taken 0A or 10 into register B, and therefore I have written B is equal to 10. As a output, here I am taking the values in decimal equivalents because it will be easier for me to do the calculations when I take the numbers in decimal equivalents. So for number F9, I have taken 249, which will go in register A, and in register B, you will get number 10. Now, when you will execute this code in Kill Microvision, in Kill Microvision register window output, we will be getting the hex numbers only. This output I have written for calculation purpose only. Now the next instruction is divab, means we are dividing A register by B. Div instruction is division instruction, and after execution of this instruction, the quotient will go to register A and remainder will go to register B. When I divide the number 249 by 10, then I will get as a quotient 24 and remainder will be 9. This is my first quotient and remainder that I have mentioned here. So when I execute this code in register A after division, I will get hexadecimal equivalent of 24 and hexadecimal equivalent of 9. Now let's go for next instruction, move R0, B. That is, we are moving the contents of register B into register R0. Here, if you observe, in the last step we got B is equal to 9. Now in this step we are doing what? We are moving the contents of register B into R0, means this 9 will be moved into register R0 because 9 is present in register B and that content we are moving in register R0, and therefore in register R0 we will get 9. The next instruction is move B, hash 0AH. Again in register B we are taking the value 10 or 0A for division purpose, and therefore now my B becomes 10 because I am moving the number 10 or 0A in register B. Now the next step is, again I am doing the division operation. I am using the instruction divab. After division, the quotient will go to register A and remainder will go to register B. Now in my case, I have A as a 24 here and now my B is 10. So when I divide this A by B, that is, this 24 will be divided by 10, right? So when 24 is divided by 10, I will get A is equal to 2 as a quotient and B is equal to 4 as a remainder. So this is how I am doing the division operation second time, and I am noting down the quotient and remainders. Quotient will be stored in register A and remainder will be stored in register B, and therefore I am getting this answer as A is equal to 2 and B is equal to 4. Now what is next step? Move R1, B. Whatever content I have in register B, that will be moved in register R1. So R1, this is the general purpose register I am using. So here move the contents of register B to R1. Now if you observe in the previous step, the value of B is what? 4. and therefore in register R1 I will get 4 because previously I have B value as a 4. So this is how I am getting R1 as 4. Now next step is move R2 comma A. That is, we are moving the contents of register A to R2 register. So if you observe the previous steps, in A register you have 2, and therefore in R2 register the value of register A, that is 2, will be moved, and therefore I will get R2 is equal to 2. So if you observe here, in register R2 I am getting 2, in register R1 I am getting 4, and in register R0 I am getting 9. So this is my answer, that is 249. So this answer I will get when I execute this code. Now I am going to execute this code in Kill Microvision, and you will observe the values that we are getting as an output in Kill Microvision. Only the thing is, for calculation purpose we have taken the values in decimal numbers. For those decimal numbers we will get the hexadecimal numbers in Kill Microvision register window. So let's go for execution of the program.
Now I have written the assembly language program to convert hexadecimal number into decimal number in Kill Microvision. So I am done with all these steps. So directly I will go for debug step. So from debug I will start the debug session of this program. Now we are going to observe the output stepwise here. So for observing the output stepwise, I will use F11 key, or I can use this option, that is step 1 line. So let's start with the operation. When I execute the first line of my program, so let's start with this operation of execution. Here you can observe in A register I am getting the value as F9 because F9 is the hexadecimal number that I want to convert. Now if I execute the next line, then move B comma hash 0AH. So here in B register I am getting the value as 0A. Now division operation will be performed in next step. So let's start with the next. Now after division, in A you will find quotient and in B you will find remainder. So in the previous calculation we already discussed, in register A we will get the first quotient as 24, but it was a decimal number 24. So for that 24 decimal equivalent the hexa number is 18, and therefore I am getting in A register as a 18, and in B that is 9. So 9 is the remainder I am getting, and the equivalent hex equivalent of 9 is also 9. So I am getting here 9. So in this window, register window, I am getting A as a 18, which is the hexa the equivalent of number 24, and for in B register I am getting 9. Now let's go for next step. I am moving the B value in R0. So in R0 I am getting the number 9. Now the next step is again in register B I am taking 10 or 0A for division purpose. So I am getting here B as a 0A. Again division operation will be performed, and after that I am getting the quotient as 2 and remainder as a 4. So in register I will find 2, that is quotient, and in remainder B I will find remainder as a 4. Now I will move the B content in register R1. So in register R1 I am getting 4 because in B register it was 4. The content was 4 and therefore it is moved in register R1. So R1 value is 4. Now next step, I will move the quotient or the value in register A into R2. So this 2 value will be moved in R2. So if you observe here, in R2 I am getting 2, in R1 I am getting 4, and in R0 I am getting 9. So 249 is the answer that I am getting for this hexadecimal number F9. So for number F9, the answer is 249 that I am getting in registers R2, R1 and R0. So this is how you can convert any hexadecimal number into decimal equivalent.